Well, hello, it's been a while since we've gotten to share this time together again. But today we're going to be learning about electric field. And it's the beginning of a new trimester. I'm excited. Well, let's go ahead and get started here. Some basic objectives. We want you to understand the basic properties of electric charge. We want to be able to differentiate between conductors and insulators. And then I want you to be able to distinguish between charging by contact, charging by induction, and charging by polarization. Properties of electric charge. There's two kinds of electric charge. One kind, get my pen up here so I can, is charges that repel each other. The other one is when charges attract. Well, like charges repel, so a positive and a positive would repel each other. Likewise, a negative and a negative would repel each other. Unlike charges, well, a positive and a negative charge, they're going to be attracted towards each other. Well, next concept here. Electric charge is conserved. Well, positively charged particles are called protons. Uncharged particles are called neutrons. And negatively charged particles are called electrons. Now, I'm sure you've discussed this before in your chemistry class. If you haven't, we'll be discussing these very briefly and not going into great amounts of detail, just simply referring to them more about their charge. So the fact that protons are positive, neutrons have no charge, and electrons are negatively is really the important concept I want you to take from this. Properties of electric charge. Electric charge is quantized. That is, when an object is charged, its charge is always a multiple of the fundamental unit of charge. Charge is measured in coulombs. So, the fundamental unit of charge, E, is the magnitude of a charge of a single electron or proton. If you have so much charge, then it's going to be a multiple of this, because you can only have 1 electron, 2 electrons, 3 electrons, or 4 electrons. So you're going to have a multiple here then of E. You're going to either have 2 electrons, or you could have 3 electrons, or 4 electrons. You can't have 3.5 electrons. So that's why charge is what we call quantized. It's either have 3 electrons or 4 electrons, and each electron has this much charge to it. So you would simply, if I had 4 electrons, it would be 4 times E, or approximately 6.4 times 10 to the negative 19th coulombs. Now, one of the things that we're going to be watching a video on tomorrow is the Millikan experiment. And this is a real simple example of it. If you want to do a little research on it, maybe YouTube it, because we're going to be watching a YouTube tomorrow. That's up to you. Transfer of electric charge. Well, an electric conductor is a material in which charges can move freely. Examples of conductors are metals. The electrons in there, which are the charges. The electrons are the charges. They can move freely. The electrons are going to float in there and just move freely. The protons can't. An electrical insulator is a material in which charges cannot move freely, and that's why charge doesn't move through that particle, or through that material. Wood, rubber, those are examples of materials that do not allow the electrons to flow freely. Insulators and conductors can be charged by contact. So even though something is an insulator, it can still be charged, and that's by contact. Conductors can be charged by what's called induction. Induction is a process of charging a conductor by bringing it near another charged object and grounding the conductor. So, let's just give ourselves a quick example. Induction is a process of charging a conductor by bringing it near another charged object, by another charged object and grounding the conductor. Well, let's say I have an object right here, and it's got these charges here. It's got all these negative charges. And I've got this other object I'm going to bring close to it. Well, what's going to happen here? Well, if this is negatively charged, and this is grounded, so this goes down here to the ground. We'll talk more about that later. There's a wire here attached. The negative charges in this object can move freely. So the negative charges over here are going to leave this area. They're going to flow. They're going to be repelled by these negative charges, and they're going to go into the ground. Well, what does that leave this object with then? It leaves this object with a lot more positive charges than it did negative charges, because the negative charges have gone into the ground. So once we disconnect this, whoop, all of these, the only thing that's left are the positive charges. So it now has a charge, and that's a process called induction. The one I skipped up here at the top, didn't mean to, is when you charge something by contact, that's charging it by conduction. And let's say that I had this charge of all these negative charges here. And I bring this object, and I bring it all the way over here so that it touches it. Well, this one was neutral, meaning it had, let's say, that many positive charges, and it had a negative charge for every one of those as well. Well, if you look over here on the left, this left side's got all these negative charges. They're repelling each other. They want to get away from each other. So some of these charges then will start to flow into this metal conductor over here. So what happens is when we pull it away, it's got what it originally had, plus it now has all these extra electrons that flowed into it, simply because they wanted to get away from all the other electrons, the other object that had this negative charge. So what I really want you to understand is when you charge something by conduction, the object is going to get the same charge. This over here was negative. This object over here turned out to be negative. When we do it by induction, all right, when we do it by induction, it's going to be opposite. This is negative, and this is positive. We can also, then the third one is by polarization. All right, a surface charge can be induced or insulated by polarization. A surface charge can be induced on insulators by polarization. With polarization, the charges within the individual molecule are realigned such that the molecule has a slight charge separation. Notice over here on the left, we've brought this positively charged object. Well, and the electrons have all realigned themselves now on the left side. So the left side of this object is negative. The right side of this object is positive. Now I'm going to use the word like. It's not exactly the same, but it's like it's a magnet, but it's not a magnet. It's just got the negative charges on the left side and the positive charges on the right side. So what we've done is we've polarized it. We've given it two opposite ends here. One side now is negative and one side is positive. And that is how you charge something through polarization. Well, that's all for tonight, folks. I'll see you tomorrow. Don't forget to put down your 2 questions. I understand there's no problems for this one, but you should have 2 discussion questions or 2 thoughts or something that you want to ask about tomorrow. I can't wait to see you.